Friends, so we are solving this problem, count collisions on a road. So there are n cars on an infinite long road. The cars are numbered from 0 to n minus 1 from left to right, and each car is present at a unique point. So we are given a zero indexed strings which denotes the directions. So the directions has like L, R or S. So L is for left side, the cars which are moving to the left side. R is for the cars that are moving to the right side, and S is the one, those cars which are staying at one place, they are not moving at all. So these are three positions or state of a car there would be. So what we have to do is we have to find the number of collisions that can be calculated in such a way that if two cars are moving opposite direction, then it would be count by 2, and if the car is colliding with the car which is staying, then it would be count by 1. So we can visualize in a better way like this. So for example, you can visualize here that all the blue cars, okay, let's say all the blue cars are moving towards left. Okay, so this is left, this is also left, and all the green cars are, let's say, moving to the right. Okay, this guy is moving to the right, moving to the right, right. Okay, and the one which is in the black colored, this you can consider that this is the staying one. So you can say this would be denoting S. But these are the blue colors are going to the left. So blue color would be L, L, and the green color would be the one which are going to the right side. So R, this also going R, this is also going R, R, but these are left one. So now we will calculate that what would be the collision count here. So you guys can observe here these two blue cars C1 and C2. They are anyway moving towards left, so they are not gonna collide at all, right? But see here C3 which is moving towards right, and it would collide with C4 which is staying, right? So when this C3 collide with C4, it will give us a score equal to 1, because it is colliding with the one which is staying state, it's not moving at all. Okay, so once they are moving, after moving they become the single staying point, right? For example, this C3 when collide with this staying one, they become a state S only. Okay, so now you can consider this would be a state S only. Okay, so when new car comes, it would be colliding as it is. This will considered as a car which is staying at one place after the collision. So here we got point 1. Now it would become stationary point. Now we are coming here. So this is moving towards right, and this C6 is coming towards left. So they are directly moving opposite to each other. So they will collide here, and they will add the value equal to 2, because they are colliding, both of them are coming from opposite direction. So in that case it will give 2, and this also become now a single state point, right? Now this C7, now this C7 would be collide with this state point. After collision they will become S, right? So this C7 will collide here. So because this is a state S, then S would be giving us, when C7 collide with this, it will giving us a score equal to 1, right? And these are anyway moving towards the right, so they will not collide at all. So what would be the final score here? The final score would become here 4, right? So this is what we have to do here. Now you guys would have been observed few things here. Okay, one thing is all those cars which are leading and going towards left, like C1 and C2, they are going towards left, right? And they are going towards right. They are not colliding at all. So if our direction string, how our direction string would have been looked here, our direction would be like this. So first two are LL, right? So it would be L, L, R, S, L, L, R, S, R, then again L, L, and then we have R, R. Now you guys can observe here that all those who are in the end, for example here, these are the trailing going towards right side, and these are the leading going towards left side. So they are not colliding at all. Leading L and trailing R, they are not colliding at all. So we can trim them, because anyway they are not contributing into the collisions at all. So we can trim in the string itself. Now we are left with this R, S, R, L, L, right? So we have to trim these consecutive RR at the end and consecutive LL at the start. Now we are left with this this string. Now what will happen is, when this car collide with this, it would become stationary and it would give the score equal to 1. Similarly, these are opposite direction, but after collision they will also become stationary, but in the point it will give 2. Now this guy is coming to the left side, so this will also give us 1. So this is what we have already explained. Now number one thing is we have to trim from the left side for the all which are moving left, and from the right side all those which are moving to the right. Now what we're gonna do here is, you guys can observe one thing, that ultimately if we count all those cars after trimming them, let's say I'm removing these, if we count all those cars which are basically which are in the movement, okay, after trimming, let me trim here, we are trimming this and we are also trimming the end. Now these cars, and only C4 is the stationary one. So if we count the all the moving cars, right, so these are the 1, 2, 3 and 4. If we count them, this would be actually our answer. Now you will say, why? How can I say this? So I can say this, that whenever we are colliding with any moving car, okay, they are actually, let's say there is a collision here, both of them are coming from opposite directions. So if we sum them, that will become 2 only, right? So moving car, if we count the moving car, that is also giving us the same collision. So all those moving car, this is R, this is going to right side, this is going to left side. So if we count this guy plus this guy, that is making 2, which is effectively equal to the collision equal to 2, because they are moving in opposite direction. So then why to bother about this stationary one? Because anyway, if they are anybody who is coming towards it, they will become after collision they will become single point, and then another moving car comes to it, that is also moving and adding 1 point. So effectively we can say that after trimming, if we count all those cars which are in the moving position, would be actually give the sum of all the collisions, regardless of whether it is happening with the moving car or whether it is happening with the stationary car. So this would give us the final answer. So let me quickly write our code. So for example, here first of all what we will do is, this is directions is our string, so let's trim it first. So let me take int n equal to whatever is the length of this. So directions dot length, this would be our length. Now we will trim first of all. So let's say we have int left equal to 0 and int right equal to what? It would be n minus 1, right? Because we have to trim for them. While left is less than n, okay, because it cannot go beyond it, and what? And it should be equal to moving towards the left, right? So directions dot char at whatever we have this left equal to this should be equal to left, right? This is what we were doing here. So it would be L. In that case what we will do is, we will be keep on increasing this left, right? So left plus plus. Similarly we have to go for the one which are moving towards the right side, similarly like the way which we were doing for the right side leading positions, right? So we would be writing for that part as well. So let me copy this code itself here, and I would be writing here right. So while right is greater than 0, right, because we are taking all those which are from the end. So while right is greater than 0 and direction at this and right equal to right. So those who are moving towards the right, we will check all of them, and we would be making it right plus plus. This would be basically our right minus minus, because anyway we are coming from end, right? So after we are getting, so this left and right would be the pointers from where our actual string without like this R, S, R, L, right? So we removed all those who are moving towards the right and those who are moving towards the left. So we will trimming this string. Now after doing this, what we will do is we will use a for loop. So for int I equal to starting from left and I less than or equal to right, because that would be our trimmed string after removing those things, right? And then we will make I plus plus. So now what we're gonna do is in this for loop we will gonna count all those moving cars, because moving cars anyway when it collides with the stationary car or collides with each other, they are basically the sum of one by one all of them effectively. So that is why we are doing this. So what we're gonna do here is, let's say we are having a answer variable. So let's say int answer, initially I am taking it equal to 0, and then you will here we will check that if directions no, spelling is wrong, directions dot char at I is not equal to s, because that is a moving car. So we are skipping moving car and then we are taking the count plus plus. So we will make answer plus plus, right? So whoever is the moving cars, anyway they are gonna collide, so we are taking the sum of them, okay, regardless of whether it is colliding with the moving or with the stationary. Effectively it would be the sum of the moving cars only. So that is why if directions.char at I is not equal to s, we are making answer plus plus, and finally we are returning this answer. So let me execute this code. So I'm executing the code, yeah, and let me try to submit it. So let us see what it goes. Okay, there is one wrong answer. So let's missing one thing, that in case if there is only one character in this directions, like here, if n equal to 1, in that case what will happen is, so we are directly returning 0, because doesn't matter if it is going left or right or whatever, it will never collide with anybody. So I have written here. So let me submit it now, which okay. So let us see what happens. Yeah, so it is 68.55%. So what is the time complexity here? You can observe here that we are first of all in initially we are taking here, we are trimming here, okay, so which is in O of n, we are trimming them, and then we are using this for loop to check the count of the moving cars. So this is O of n, and we are not taking any extra space except few variables. So this is O of n time complexity and constant for the space complexity. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.